Hi everyone, in today's lesson we're going to talk more about identities. This time we're going to talk about sum and difference formulas or sum and difference identities. So we already know the exact value chart. We use that when we have angles of 30, 45, and 60. Now this chart right here is all of the sum and difference identities. Don't worry, you'll never be asked to memorize these, but this just proves the sine of two angles, A plus B, will equal sine of A times cos of B plus cos of A times sine of B, and so on and so on. So how will you see these questions? Let's take a look here at this first example. It says, find the exact value of each in simplest radical form. So normally when you've heard exact value, you used to think exact value chart. However, if you notice here, you don't have a 30, a 45, or a 60. They're asking you for sine of 50, cos of 20, and so on and so on. So we're not really going to be able to use this yet. What you want to do is take a look at the structure of this. It goes sine cos minus cosine. So over here, you're going to look for that. You're looking for sine cos minus cosine. So close to this one. So I think I see it right here. Sine cos minus cosine. Sine cos minus cosine. So the one that we're going to use here is this formula. So we're given this side, right? And we want to go backwards to find this side so that we can evaluate it. So if you take a look, this is the formula for sine of A minus B. So you can just figure out where your A and your B's are by looking here, A and B. So here would be your A, here would be your B. So you basically have this part and you need to go backwards to here. So this would be sine of A minus B. So sine of 50 minus 20, which is the same thing as saying sine of 30. And hey, you have that in your exact value chart. Sine of 30 is a half. So the exact value here for this problem is simply 1/2. Okay, how about example number 2? It says find the exact value of each. Cosine of 75. Well, again, I don't have a 75 here. I only have a 30, a 45, or a 60. But if you examine these three numbers, we can get 75 by adding 30 and 45. So we're going to be able to use one of these identities here. So let's break this up to cosine of 30 plus 45. Now, it would work the same if you had done 45 plus 30, so don't stress about the order. Remember that addition is commutative. So we're going to write down the cosine of A plus B formula. So we're going to go up here, and we're going to highlight the formula that we need. So cosine of A plus B. So the format is cos cos minus sine sine. So it's going to be cosine of A cos cos minus sine sine. Now, if you want, you could have labeled this is your A and this is your B, and the formula was cosine of A cosine of B minus sine of A sine of B. So now let's use our exact value chart. So on your exact value chart, let's look for cosine of 30 and then put that there. So cosine of 30 is your rad 3 over 2, and cosine of 45 is your rad 2 over 2. So rad 3 over 2, and these are attached by multiplication, so we're going to multiply rad 2 over 2. Minus, if you look at the chart for sine of 30, you should see that it's 1/2. Same thing for the chart for sine of 45, it's rad 2 over 2. So to simplify this, order of operations tells us we're going to multiply before we subtract. So remember, when we multiply fractions, it's tops times tops, bottoms times bottoms. And when you multiply radicals, you can just multiply them the inside. So 3 times 2 is 6. And then 2 times 2 is 4. And then this one will simplify to rad 2 over 4. And then if we can get this into one single fraction, since it has a common denominator, we can subtract the tops and keep the bottom the same. Now, because the radicals aren't the same, you can't technically subtract them. They're not like terms. So this would actually be your final answer in simplest radical form. Okay, let's take a look at the next page. So here is different ways that they could ask you. They could give you different information. So their first thing here, they're telling you that sine of A is 3 over 5. Cos of B is negative 12 over 13. And they say that A is between 0 and 90. 90 is pi over 2. And B is between 180 and 270. Pi is 180 degrees, and 3 pi over 2 is 270. So you have to take a page out of the trigonometry textbook here, and you have to be able to remember those reference triangles. So they tell you that sine of A is between 0 and 90. So we're going to draw part of the bow tie in quadrant 1. So remember, like, this is the bow tie that I'm talking about, right? And all I want to graph for A is this piece, because that's between 0 and 90. So I'm going to draw that over here. And I'm going to put my angle here in the middle. And I tell you that sine is 3 over 5. Remember that sine is opposite over hypotenuse. So I can go ahead and label the opposite side to be 3 and the hypotenuse side to be 5. Now I'm going to label the next part. The next part is about cosine of B. Okay, they say that B is an angle between 180 and 270. So that's an angle in quadrant 3. So we're going to draw this triangle here, and we're going to label B our angle in the middle. And they tell you that cosine, remember cosine is A over H, adjacent 12 over hypotenuse 13. Now you're going to notice that I don't label the triangles with the negative. The negative just tells me that cosine would be negative in quadrant 3, which it is because of all students take calc, right? All students take calc. So tangent is the only thing that's positive in quadrant 3, therefore cos will be negative. So in order to evaluate what the questions are asking, parts A, B, and C, we need to finish these triangles. So you're going to have to use the Pythagorean theorem to find the missing sides. So take a minute, pause the video, use the Pythagorean theorem to find this side, and then hit resume when you're ready for the answer. Okay, so after you do the Pythagorean theorem, this should give you 4, and over here should give you 5. So now that we have the two pictures, we can answer the questions. So first thing for part A, find sine of A plus B. So A plus B is this formula. So what I'm going to do first is just copy it down so I know what I'm using. So sine of A plus B is going to equal sine of A times cos of B plus cos of A times sine of B. So let's see what information we have. We have sine of A, that's 3/5. So I'm going to go ahead and put that here. So 3 over 5. What else do I have? I have cosine of B is negative 12 over 13. So I'm going to put that here. And these are being multiplied together. That's why I put them in parentheses. Parentheses aren't necessary. I just like to do them. All right, now let's keep going. We need to find cosine of A. So that means I need to go to the triangle that has A, not B, but A. So cosine of angle A is adjacent 4 over hypotenuse 5. So cosine of A is 4 over 5. And we know in quadrant 1, all things are positive, so I know cosine of A will be positive as well. Now I want to find sine of B. So we're going to look at the B triangle. Sine of B is opposite over hypotenuse. So 5 over 13. So now we have to check the sine. Since we're in quadrant 3, tangent's the only thing that's positive. Therefore, sine must be negative. So now to find the answer to this problem, all you have to do is type this whole thing into the calculator just the way that you see it. The reason why we couldn't do that before is because we had radicals. But if there aren't radicals, your calculator has the ability to spit this out as a reduced fraction. So take a minute, pause the video, and then hit resume when you're ready for the answer. Okay, so I got negative 56 over 65. And that is our exact value of sine of a plus b given these conditions. So what I actually like you guys to do for homework is try to see if you can do part B. Try to see if you can find tangent of a plus b using this formula here. I know there's a fraction. I know it's a little tricky, but we will definitely start off class tomorrow going over this one. All right, have a good night.